All right. Today, I think we finished chapter 3 with all the basic rules of adding, subtracting, multiplying, dividing of integers. Now we're going to start chapter 4. Number theory. Section 1 deals with divisibility. What does it mean to be divisible? What does that mean? To be divisible means that one number fits into another number evenly. By one number, I mean other than one and itself. Because if a number only has one in itself, those are prime numbers. Prime numbers only have one in itself that it fits into. So what are factors? Factors are sets of numbers that, let's say, fit into another number evenly. When we say evenly, has no remainder. See what's happening here? Every time we define a word, we use words that we have to define also. So we have to know what each of these words mean in our definitions. So let's look at a fraction. The top number is called the numerator. The bottom number is called the denominator. Its quotient. Its answer is called a quotient plus whatever remainder, if any. Eight divided by 2. 8's the numerator, 2 is the denominator. 8 divided by 2 is 4 with no remainder. So we just write 4. How about 7 divided by 2? We do it this way. 2 fits into 7 3 times. 3 times 2 is 6. This number here is a remainder. This number up here is the quotient. This is the divisor. And this one's called the dividend. So what this thing is, the quotient. Remember, the first number here is a quotient. So it's 3 plus the remainder. The remainder is 1 over the divisor. So this is how fractions are written. Yeah, they all have their own different sets of names or definitions of them. So next definitions. If the remainder equals 0, when A is a number, is divided by B, that's another number, then we say that A is divisible by B. If the remainder is 0, then A is divisible by B. Or we can also say B is a factor of A. Or we can say A is a multiple of B. Or we can say B is a divisor of A. Or we can say that B divides A. This one is usually written like this. B divides A. So 2 divides 12. Yeah, 2 divides it because we have no remainder. All right. So another definition that we can use for division or divisibility or divisible said if we have two numbers, A over B, where B does not equal 0, equals some number C. If A over B equals C, then A has to be a multiple. A is a multiple of B. So far, so good. These are different ways we can say it. We're going to get to at the end of this section, we get to divisibility rules. Odd numbers versus even number. Okay, an even number has a remainder of 0 when divided by 2. So it has no remainder if it's divisible by 2. An odd number has a remainder of 1. When divided by 2. So basically, an even number will look like this. Some number is even. If it's divisible by 2, it has a quotient plus no remainder. So what that says is this top number is equal to the quotient times 2. An odd number, if I divide it by 2, I have the quotient plus a remainder of 1. So twice the quotient plus 1. That's how I know if it's a number is odd or even. For example, 8. 8 divided by 2 is 4, the remainder of 0. So 8 is even. 9. 9 divided by 2. 2 goes into 9 4 times with 1 left over. So 9 is an odd number. The definition. So for any, we're dealing with whole numbers. We deal with integers, but whole numbers, because I don't want to deal with negatives just yet. For any whole numbers A and B, where B does not equal 0, B divides A if and only if, again, I'll use this from now on, IFF, that means if and only if there is a unique whole number Q such that, I'm going to start writing ST, A equals B times Q. So what that's saying is if B divides A, then A is equal to B times some unique number Q. Let's see what this means. Here's an example. 21 divided by 3. We know 3 goes to 21 7 times. So we know that 3 divides into 21. So if that's true, remember this is A and this is B. The answer 7, that's Q. That's true if A equals B times Q. And Q is unique because I can't put a 9 there. It wouldn't equal 21. I can't put a negative, or like I'm only using whole numbers. Can't use 100 because that wouldn't fit. We can also look at further into this thing. It says if C divides A and C divides into B, then C divides into the sum of A plus B. Let's say, let's just look at this example. Let's say C equals 5, A equals 20, and B equals 10. Five is into 20. That's 20 divided by 5. We know that equals 4. And this one, 5 goes into 10. 10 divided by 5 is 2. If I add them together, I get 6. But what this rule says is 5 is also divisible into 20 plus 10. 20 plus 10 is 30. 30 divided by 5 is 6. So that's the proof of that. So if a denominator or divisor is evenly factorable into two numbers, then the sum of those two numbers is also going to be the same answer. It doesn't matter how many you have. We can say C goes into A, C goes into B, and C goes into G. Then C goes into A plus B plus G. Same logic. Conversely, I mean, it's the opposite. If C does not fit into A and C does not fit into B, then C does not fit into A plus B. All right, so that's how that goes. All right. The divisibility rules. The divisibility rules are shortcuts to determine if a specific number is a divisor or factor of another. Okay, I've used the word factor. I've used the word factor by that. What does that mean? (21) divided by 3. Is 3 a factor of 21? Well, let's see. 21 is made up of 3 times 7. So we have 3 times 7 for 21 over 3. If they cancel, then yes, 3 is a factor of 21. And the answer is 7. So that's whenever I use a factor, that's what I'm talking about. So if we take a number, prime factorize it, top and bottom, cancel, it's the same. Whatever's left is your final answer. 2, 3, 4, 6, 7, 8, 9, 10, 11. Okay, these are if the divisors are. How can you know if a number is divisible by 1? Every number is divisible by 1. 4 is equal to 4 over 1. It's divisible by 2. A number is divisible by 2 if the last digit of the number is, if the last digit is a 0 or an even integer. A number is divisible by 2 if it ends in a 0, like 10. 10 divided by 2 is 5. Or an even integer, 26 divided by 2. 2 goes into 2 once, 2 goes into 6, 3. As long as the last digit, this is the last digit, 2, 4, 5, 1, 6, that number is divisible by 2 because it ends in an even number. Two goes into 2 once, 2 goes into 4 twice, 2 goes into 5 twice with 1 left over. 2 goes into 11 5 times with 1 left over. 2 goes into 16, 8. So there's the answer. A number is divisible by 3 if the sum of the digits in a number is divisible by 3. Let's try something small here. Is 18 divisible by 3? Well, the numbers are 1 plus 8 equals 9. Is 9 divisible by 3? Yes. So 18 divisible by 3. $252. Is that divisible by 3? Well, let's find out. 2 plus 5 plus 2 7 plus 2 is 9. 9 is divisible by 3. So yes. 3 goes into 25 8 times with 1 left over. 3 goes into 12 4 times. So if you add up all the digits and it's the sum is divisible by 3, then the whole number is divisible by 3. A number is divisible by 4. If the sum of the last three, let me see, by 4. I forgot about that one. A number is divisible by 4 if the sum of the last 2 digits are divisible by 4. For example, 316. Is that divisible by 4? First off, it's got to end in an even number. That goes without saying, because 4 is made up of 2 times 2. So since 4 goes into 16 4 times, we know this whole number is divisible by 4. 4 goes into 31 7 times. 7 times 4 is 28. 31 minus 28 is 3. 4 goes into 36 9 times. So it only works for numbers with 3 or more digits. Well, it works for 2 of them, but we don't need this rule for that. So, for example, 16 is 16 divisible by 4? Yeah, 4 times. So it works for numbers. It works easier if you have three or more numbers. A number is divisible by 5 if the last digit is a 0 or 5. If the last digit's a 0, then it's divisible by 5. Mm. 8. Okay. It's divisible by 6 if the number is divisible by both 2 and 3. Remember, to be divisible by 2, last digit is even or 0, and 3, sum of the 2 digits is divisible by 3. It's got to work for both of those. Both of those things have to exist. Both those conditions have to exist. 7 is a very complicated one because it's a process. It's a series of steps you got to do, and I'm hold off on that one. because I don't want to mess it up and then really screw your heads up. So we'll come back to that one. 8. A number is divisible by 8 if the last 3 digits are a number that is divisible by 8. Now the corollary for that one, well, so if the last 3 numbers is 2064 divided by 8, the last 3 digits form 64. Is 64 divided by 8? Does that exist? Yes. So that means the whole number is divisible by 8. Or since 8 is made up of 2 times 4, 2 times, so it's 2 times 2 times 2, or 2 times 4. The number has to be divisible by 2 3 times, or the number has to be divisible by both 2 and 4. Or the number is divisible by 2 3 times. Or the number is divisible by both 2 and 4. A number is divisible by 9 if the sum of the digits in the number is divisible by 9. Similar to that of 3. So yes, if it's divisible by 3 twice, then it's divisible by 9. Same thing. Is 4617 divided by 9? Is it divisible by 9? 4 plus 6 plus 1 plus 7. 4 plus 6 is 10, 11, 18. Since 18 is divisible by 9, then this number is divisible by 9. A number is divisible by 10 if the number ends in a 0. $100. Is that divisible by 10? Yes, because the zeros cancel. We're left with 10. 420 ends in a 0. The zeros cancel. 42 divided by 1 is 42. What's the rule for 11? And the last one today. And the last one today. Numbers divisible by 11. The whole number is divisible by 11 if and only if the sum of the digits in the places that are even powers of 10 minus the sum of the digits in the places that are odd powers of 10, if that difference is 11, is divisible by 11, then the whole number is divisible by 11. What does that mean? Right, for example, this is the ones, that's tens, that's hundreds, that's thousands, 10,000s, 100,000, millions. So this one is 10 to the 0. This one is 10 to the 1. This one is 10 squared. This is 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6. Even places, odd places, subtract them. So it says the sum of the digits that are in the even powers. Even powers are 2, 4, and 6. These are the powers. So add up those numbers. 8 plus 7 plus 9. 8 plus 7 is 15, plus 9 is 24. So that's the even numbers. Do the same thing with the odd. The odd ones are 1, 3, and 5. So those numbers are 4, 1, 8. That's 5 plus 8 is 13. So I take 24, that's the even numbers, minus the 13, that's the odd locations, subtract them. Is this number divisible by 11? Since that's true, this whole number here is divisible by 11. I know, it's a lot of steps there. All right, that does it for chapter 4, section 1. We will continue chapter 4 next time. Any questions? Any questions, Lisa?
No question.
Right. No questions? All right, perfect. So then I will see you guys on Wednesday. Remember, next week is spring break. So we'll have a quick class on Wednesday. Hopefully we can finish up the chapters. Only 2 sections left and they're pretty short. So we'll see about that and I'll see you on Wednesday. Have a good day.